All right, good afternoon, everybody. Welcome to the Rancher Kubernetes Masterclass today. If you've been with us before, you might have noticed we are using a different webinar platform. So hopefully everybody had an easy time getting logged in and situated. My name's Connie Lynn, and today you can see me on camera, which is also a new feature. I am a global events manager at SUSE, and will kind of be your host today. Our speaker today is Staff Software Engineer Luther Monson, and we also have Nick Gerace, Software Engineer at SUSE, helping with Q&A today. So a quick rundown of our master classes. They take place between 45 to 75 minutes. We have a total of, I think, 90 minutes for this class, so feel free to stick around for the whole time if you have lots of questions. You should be able to see a Q&A, a questions tab in your webinar interface. So if you have any questions as the class is going on, you can pop it in there and we will do our best to answer all of them. We do have a channel on Slack that's dedicated to the masterclass. So head over to slack.rancher.io to join that channel. It's an open channel we can access even after the masterclass concludes today, so we can keep the conversations going. And something new to share today, aside from the new webinar platform we're using, is we have launched a new community site for both the Rancher and SUSE communities. You can check this out at community.suse.com. It's a place where you can develop your knowledge, hands-on skills, and network with everybody from SUSE Rancher and within the community. So every month, explore a new theme that's supported by a wide variety of content, including guest speakers, training classes, office hours, and more. You can create an account today and start getting familiar with it. All right, and hopefully people were able to get logged in and situated all right. I'm gonna hand this over to Luther, and we are going to get started with today's class.
Okay, everyone. Hopefully you can hear me. Leave some notes if you can't. And if there's any issues with quality, etc. I will be sharing screen too. So if that stuff starts to not work out so well, please raise your hands, put questions out there saying things aren't working so we know to try to fix them. As Connie said, this is the first time we've used this software, so we'll see how this goes. So here is my title slide, Kubernetes Masterclass, Scaling Kubernetes Nodes from Rancher. So if you're here, you probably want to know something about scaling. That's kind of what we're talking about today. There was already a question on kind of what we're scaling, so I'm going to be pretty explicit here. This is going to be based on the Rancher 2 version 2.5 is what I'm running this off of, and it is RKE1 clusters, and it is going to be the machine drivers. Specifically, I'm going to be using EC2 to do all of my demonstrations today, but it is actually applicable to any machine driver and any node pool. So if you have your own add-on machine driver that you use, this stuff will all apply. This question that was asked was actually, is this doing like K3s or RKE2, things like this? It's not. This is going to be the original RKE1 node pools. Okay, so who am I? I am Luther Monson, Staff Software Engineer, and I have some links if you want to find me. I do not tweet, but I collect followers, so feel free to follow me. I'm a Rancher 2 engineer. I've been with Rancher and now SUSE for 2 years, and I do some of the engineering support around here, and I also contributed to some open source projects. For instance, I'm a contributor to Flannel, which is one of the CNIs out there that Kubernetes uses. I actually work on a lot of the Windows products around here. We have RKE1 supporting hybrid Windows clusters, and I do a lot of that work, and we will eventually have RKE2 supporting Windows clusters, and I will be doing a lot of that work too. There is also a problem with me, which is I'm not good at PowerPoint. So just if anybody sees anything that's screwy in this, I'm sorry. We also have Nick Gerace. Nick Gerace is a recent hire here. I believe you've been here 6 months, I think, Nick. And he is also a Rancher 2 engineer. He also is a maintainer and contributor of open source projects. He is got his own little things out there. He's got a nice, he has a controller that he wrote in Rust. It does some monitoring of your clusters. If you want to go check that out. He also is a Rustation, hence he's using Rust for his controllers for some reason. Loves Clippy, huge fan of Clippy, not sure why. And he actually is way better than me at PowerPoint. That's actually really true. I've seen his slides. He's going to do a SUSECon presentation pretty soon, and that's pretty legit stuff he's been working on. Okay, so scaling. So I'm going to be going over kind of the basics, where some of this stuff started, kind of where it came from. I think that we have to go back to what Kubernetes is doing themselves for scaling. So I'm going to be starting off in the Kubernetes world, and I'm going to introduce you guys to the HPA, the VPA, and the CA, which is Cluster Autoscaler. I'll go through the acronyms here. HPA, Horizontal Pod Autoscaler. VPA is the Vertical Pod Autoscaler, and the CA is the Cluster Autoscaler. So I'll have individual slides for all those, and we'll kind of discuss kind of their architecture, what they do, et cetera. And then we will then move into Rancher and kind of the way we do some of the things. We have some of the same elements, and I want to kind of show you kind of what we implemented and how you can use those tools to your advantage. And then I will go over sort of this cloud provider that we've created for Rancher 2. The cloud provider is going to have a demo as well. I would also like to preface this whole entire talk with stop me early and stop me soon. If you have a question, please ask it. Nick is going to grab them and either answer them right away, or he's going to stop me. Nick is going to be your eyes and ears while I'm doing the presentation, and he will take your questions and bring them up to me. So feel free, just put them in there. The more questions, the better, and then we will be figuring this out. Okay. Next slide. We do have someone who's asking when it will start, which is a bad sign. So maybe we better give this a quick pause here just to make sure everyone's seeing stuff. I am gonna, anybody wants to, yeah, that's probably not a good sign, is it?
I am going to ask the chat real quick. Feel free to submit a question as an answer and say if you can see the chat or if you can see the PowerPoint, please let us know. Yeah. It's all good? Okay.
Well, we'll go with that then.
All right. I see stuff. That is inspiring. I think we're good.
That's actually perfect. Great. All right. So sorry, Abhishek. Works for everyone else. Okay. So horizontal pod autoscaler. So the horizontal pod autoscaler is pretty ubiquitous now with Kubernetes. If you are in fact using Kubernetes, you've probably run across this. They're shorthanded as HPAs, and it's kind of built right in. There's a controller built right into Kubernetes now, and it is a very common thing to set up. But actually, I believe the default Helm 3 chart, if you go do a Helm 3 create chart, it will automatically add some of these details in there, and it'll put a values YAML there for you to update how many pods you want, et cetera. But the thing to know about the horizontal pod autoscaler is you can see this graphic here. I love this graphic, actually, because it shows you the pod scaling horizontally, obviously. So if you need more pods, this guy adds more to it, right? So you go from 1 to n pods. His job is really to just read metrics, figure out what's going on, and then add more based upon need. So good examples of how this thing would work would be if you are going to have a website and you have a lot of traffic during, say, 9 to 5, Monday through Friday. Well, you can try to get some rules going so you can add the HPA's logic to add more pods during that time frame. One could argue that this is sort of a way you would have added, like if you were doing EC2 back in the day, you would have an autoscaling pool, and you could have timed timed adding more to the pool and timed removing from the pool, right? So something like that would be kind of the Kubernetes way of doing it. You would just be adding pods and processes and containers instead of adding full entire nodes. The other examples here I have written here is if you have a deep queue, and you have workers, you want to add more workers to scale to scale up to take a deep queue and make it smaller and process more work. Great usage, right? You could take metrics, you could then watch the queue gets big, add some more pods, right? It's basically an increment or decrementer on this scale value for a deployment is really what it comes down to. And I'm going to go through a demo of that. But it's very straightforward. It's very straightforward. It's like, I have 10, I want 20, here's some more pods, right? And it'll just, deployment set will let you, replica set let you up that, and you're good to go. So it's pretty straightforward. So the other fun thing about the HPA, though, is actually the rolling updates. Actually, that's a feature I really like, is you can roll new versions of an image and have it added to the same pool of pods and then remove the old ones. That's actually a pretty neat feature. So the Kubernetes people tend to do a lot of work in this HPA world. And you can see here, I have this docs list linked here. It kind of just walks you through everything the HPA does, how he functions, and kind of some of the metrics you can use to have him function. He is very much a first-class citizen in Kubernetes. He's worked on quite a bit, and he's kept up to date. And you're going to find it in I think anything like 0.8 plus. I forget when they added that, but it's been around for a while. Okay, so the next thing that they started going into when they were doing scaling in Kubernetes land was to work on vertical pod autoscaler. So the vertical pod autoscaler is actually an out of tree. Sometimes you'll hear this term of in tree cloud providers versus out of tree cloud providers. I also call this an out of tree sort of functionality because it's in this github.com/Kubernetes/autoscaler repo. So the autoscaler repo ends up having a couple of additional tools, including the cluster autoscaler, but it also includes this vertical pod autoscaler. So this is the architecture. This is actually in their docs there that they have. And it's a little complicated, and honestly, it's a lot more beta. It's a lot more limited. It's not really something that's completely sorted out yet. I personally never run this thing, and I don't think it really truly does what people think it does. If someone's gotten it working and they love it and swear by it, I want to talk to you, because I don't honestly know for how the limitations work on this thing, like if you're really getting what you want out of this. But the basic idea is it has right here in the center, you'll see this VPA controller, and you'll see the recommender and the updater. And the basics are it reads metrics, and it recommends changes to pods. It'll recommend memory and CPU changes, basically. So if you have a pod, the idea is if you have a pod that has too much memory consumption, it will make a recommendation to up its memory limits, right? So let's say it's using, you set it up to have a limit of 2 gigs and it's pushing like 1.8, 1.9. It's like, maybe we need to update him. So it'll just automatically do that for you. But there's some limitations here. For instance, I don't think you can't change pod, you can't change that, like, you have to restart the containers to make some of that stuff work. So there's like, it works, but it doesn't. Like, I'm not sure if there's any downtime caused by these things. Like, seriously, if anybody's running this in production, I would like to talk to you, because I just want to see what your use case ends up ultimately being, because I just find this thing to be a little kludgy. It's the updater, by the way, obviously recommender makes a recommendation, updater then goes and does the updates. That's pretty much the architecture. It's just not amazingly complicated, but it's doing a lot of work behind the scenes. And there's limitations of Kubernetes and how they run containers and pods that just make this thing a little bit weird. But I think the critical piece here you can see here is this on the top left there, it says Prometheus initially. So, I mean, I want to keep coming back to a single thread that keeps happening through most of these, architectures for autoscaling is metrics. It's pretty critical that you're running some monitoring and you're getting metrics and you're making decisions based on that. Yeah, the limitations, there's a whole list of them. If you go to that repo and you can take a look at it and see if it works for you, maybe it does. It's kind of what your org really requires, to be honest with you. If you can make this work for you, then I think it could be a good solution. But there are in fact limitations to it, and they're listed and they're pretty clear about what it can and cannot do. Okay, so vertical pod autoscaler done. Let's talk about the cluster autoscaler. So the cluster autoscaler is a little bit more sorted out, and this is pretty much what we're going to be working with for the rest of this masterclass. The cluster autoscaler it's very much based on pods, and if you look over here at this architecture diagram, this is actually an EKS graphic that I stole. You'll see here that it's basically sitting there at the top, and he's looking to see if there's pods who need to be scheduled. And I think the easiest way to kind of explain this is, I think most people understand that if you have a worker node, there's some sort of limitation that you can configure of how many pods per node you should be running. Some defaults are like 110, for instance, per node. You can configure that if you want. Think of it this way. When you get to 110 and you need 111, the cluster autoscaler will spin up a new node, and then you can have your 111th pod go to the next node and in the cluster, and then you'll be able to scale horizontally. The cluster autoscaler is technically a horizontal scaler, right? It'll horizontally scale out nodes until you've reached your capacity, your limitations, whatever it might be, and then it'll scale back down when you do not need that capacity. That's the gist of it. It's not going to do any resizing of nodes. It's like, for instance, like the vertical vertical pod autoscaler. He would resize pods, to say use more or less memory. The cluster autoscaler does not do that. He will not say, I'm in EC2, I'm going to spin up a bigger instance because, right? You kind of have to make some of those decisions yourself, and kind of do your own configurations. So yeah, he's very much I need more pods. I do not have capacity. Plus my nodes. That's the basic gist of what he does. Honestly, the Helm chart for this guy is great. It could use a couple of updates, but it's good as far as I'm concerned. It's very full-featured little rig, and they also have the SIG, the special interest group that does all the work on this, is SIG Autoscaling, and they're an active group, and the cluster autoscaler gets updates. It does do what it says it's going to do. I will show you a demo of that. It will choose which nodes to delete based on capacity, and choose nodes to add based on capacity, and it does just that. It is based off of these things called cloud providers, which is a term that was used also if anyone's done any of the storage stuff. You have the CSIs, right, the cloud storage stuff. If you have a cloud provider, there was these in-tree ones, out-of-tree ones, et cetera. They always use this term cloud provider, and it really was sort of ubiquitous for EC2, Azure, these sort of things, like the big cloud provider, the big public, the public APIs. So you lost the video. Great. Let's maybe pause for a second here. And what do we think?
I think we're good on our end. I can see you. I can see the slides.
All right. Well, sorry, Juan. We're going to keep going. Keep pinging if it's a problem.
Folks, sorry for interrupting, Luther. Folks, feel free to message me if you think everything's fine. Still works great. Okay, a lot of folks are okay. All right, pump the brakes. Good. My inbox is exploding. Thank you all.
Yeah, it is. That's good. Okay, I did see Caleb actually asked a question. No, sorry. Does it consolidate? So Chris, does it consolidate pods on scaling down? Yeah, it does. So it's when the node's going to be that's the drain and cordon feature. Really, is what that is. Is that you're gonna drain and cordon the node and then kill it. And I'm going to cover a little bit of that later. You want the kubelet to evacuate the node before you kill it, and that's the functionality that makes that happen. So. And we're going to show some of that stuff later. So
there's another question as well, right above, I believe, the one you just read.
Oh.
Is the rancher autoscaling versus cluster autoscaler?
Yes, that's exactly what we're discussing. That's what the entire class is on.
All right, cool.
Good question, though. But yeah.
I think we're good. And now people are trolling me with smiley faces. So, all right, you guys are winning this time.
Sure.
All right.
So we have another feature here that the cluster autoscaler is working on, which is the cluster API cloud provider. That's what they call it. So cluster API is this new API where it's like, this is the definition of a cluster. And now cluster autoscaler also speaks that. I'll be honest with you, I didn't actually look much into that. don't use a lot of cluster API in my day-to-day. I know that there's some people like the VMware guys are working on cluster API pretty heavily. So if you're a vSphere user, there's a good chance that you understand cluster API and you like it. Understand that the cluster autoscaler is doing some work around that. Could be beneficial to you. I'm not sure, but cluster API, eventually is supposed to be this interface that sits between something like Azure, EC2, vSphere, et cetera. And you just say, this is what I want my cluster to look like. And he does it behind the scenes, right? So there's some sort of an operator that'll go do all that work for you. And you just have to speak a simple definition language. We'll see. That's a lot of cluster API stuff is still in progress, and we implement some of it in Rancher 2 itself. So I don't know. It's some new stuff. We'll see how that goes. Ultimately, the cluster autoscaler is trying to support it just like everyone else is. Okay. Next slide is node pools. The node pools that we actually have in Rancher. So if you're not a Rancher user, I'm going to actually show you a couple of things here because there are some people who are probably new to everything. So I'm actually going to do a quick little demo, and I'm going to try to share my screen and hopefully not crash this thing. So here is... Hopefully everyone is about to see a Rancher window. Haha, there it is. Hopefully everyone sees it now.
Yep.
Okay, so this is the Rancher UI. This is the Cluster Manager UI, not the Cluster Explorer UI. Go look at Cluster Explorer if you want to go do that. I'm not really going to cover it. Cluster Manager is where I'm doing all my work today. So I have 3 clusters here. You can see Autoscaler 1, that's where I'm going to do my demo later. Autoscaler 2, I'm going to show you a couple things in there. But I would like to show you just in general, what am I actually even talking about, just so you understand this. So I actually have add a cluster. I'm going to select cluster type of EC2. I want to be clear that down here we say this new nodes in an infrastructure provider. This is what we call node driver clusters. It is something that is powered by this. If you go here, oops, I have to go global here. Yes, no, drivers, sorry. So you'll see a list here. We have cluster drivers, we have node drivers. So this is all based off of essentially Docker machine. We forked it and made a thing called Rancher machine. We added some functionality. And under the hood, if you have a Rancher machine / Docker machine provider, you can actually upload them and you could have your own infrastructure provider to make clusters. So this is stuff that you could write. And you'll see here we have Google's, DigitalOcean's, Azure's, Amazon's, which were the ones you saw in the UI, but you could also add Linode, Oracle, cloud infrastructure, OCI, OpenStack, et cetera. So I just want to make sure everybody understands that this is all based off of these node drivers. And if you do not have a node driver in here for your setup that you use, you can go find one. Like someone probably wrote one. It's actually a pretty common tool to write a node driver for a cloud. So if you're in some offshoot cloud that's not as popular as the rest and it's not maintained as well as these ones, don't fear. It's very possible that someone's made one of these for you already. If they haven't, they're actually really easy to make in general. There's a lot of documentation on how to do it. Just write a little bit of Go for some creates, updates, and deletes basically, and you can have it interfacing pretty good. And that also works if you have your own API. Let's say you have some in-house sort of setup where you are, maybe you're sitting on top of EC2 because you don't want people to have access to EC2, but you have your limited set of APIs. You could write yourself a machine driver for this, and you could use this functionality as well. So there's a lot you could really do here. Let's go back here. I'm going to go add a cluster. I'm going to select EC2 because that's the one that I've kind of already set up here in my rig. So I'm going to do Autoscaler 3, doesn't matter what you call it. I'm going to do sort of a server rig, which is going to be a control plane. And then I'm going to actually choose the monitoring one because it's a bigger node. And I'm going to do an agent. It's kind of a K3 setup, so to speak, right? I'm going to do a worker here. I'm going to pick this scaling node just because I know it's smaller. And all these things I'm going to leave default. If you haven't seen Rancher before, we keep some versions of Kubernetes for you to select. We have our kind of flavor for RKE that we use, and then you can choose your CNIs. I'm going to just leave this all at default, and I'm also going to set the entry provider because I know that that's actually required for how this autoscaler is set up. So this is kind of the basic of what I did to get my autoscaling node working. That's it, create, and you're good to go. So I'm going to boot this up here. and I'm going to look at nodes, and you're going to see that in behind the scenes, no drivers going out, he's making nodes, right? So you can kind of already start to understand that if you have the node driver creating nodes out in EC2, that something like this is very easy. I can just hit +++, and it'll start adding more nodes. And he will go do the exact same replicatable process. He will go create an EC2 instance, he'll log in, install Docker, connect it back to the cluster. Very simple. You've basically got yourself, you basically have yourself a, scaling cluster, except you have to deal with this plus or minus button. And you also could come in here and just set it to 2, for instance. Like you have this count field, right, that you can mess with. So what does that give us, right? So like, is incrementing, decrementing, and setting everything that we need? It kind of is, but note a couple of things here. If I actually add another one, you'll see here I have agent 5, it writes in agent 6, right? So this whole thing back before our updates was based upon incrementing and decrementing a counter and then adding that and appending it to the node name and then adding an additional node to the pool, and there you go. Now, this also works the opposite direction. So in pre-256, so I'm going to be talking about my updates that I made in 256 and later. So let's say pre-256, if I hit minus, it's going to delete 6, right? That's not so great if you actually know which node you want to delete, et cetera. So I'm actually going to show you how we fixed that, how we got across, how we took care of that. But I think you guys can kind of understand here. You have a node pool, increment, decrement. And also, just to be crystal clear, if you view a node pool in the API, you will see right here, quantity 5, okay? And if anybody doesn't know, full-featured API on Rancher, go get yourself a bearer token, and you can access it, and you can modify these things, and Rancher will do the work behind the scenes for you. So if you, for some reason, wanted to write your own autoscaler, you could just ask some questions of some metrics and say, I think I need to add a new node. So you can just go make a request to the API, change that to 6, and you can send it over. And then if you go back over here, you'll see a 6 node. He gets added. That's just what happens, okay? So full-featured API can do it. It already can do this kind of scaling functionality. You're gonna have to write a little bit of, your kind of logic around it. But yeah, you can, if you have metrics, you decide when you want to add a node, boom, you can add it. We've already got some of that stuff. But we needed to add some more. So let's get further along into this. So in pre-256, I just showed you that. We were not able to do selecting a node and deleting it. So I'm going to show you that right now. So this is what we've added here is the scale down feature. If you go here, just go here, I'll just select 2 nodes, whatever. And I just click scale down. We now have added it so that you can select the node that you want gone from the pool. This is a huge change, actually, from where we've had the node pool for probably 3 years. I think the code I was modifying is 2 or 3 years old. Is kind of a complete rewrite for how the node pool controller was handling the pools. It used to be you plus or minus, we just take the name and append the integer, and you're good to go. But we had to make a way for us to select which node to drain. And I will go over those API changes later, but I think you guys all just saw it right there. If I don't want 2 and 3, I can choose them. Even in this menu right here, there's a scale down functionality. So I can just say, I don't want it, be gone, and then the controller takes care of it. He'll delete it out of EC2, it'll all get cleaned up, everyone's happy. So now the fun part about that is actually the ability for us to pick the nodes and set a time, sort of a time for when this needs to happen. So there's additional functionality, which I will show how the API actually works, which is you can say in the future, take this node out, right? So you could say 10 minutes from now, an hour from now, something like this. You could also decide that this node needs to go. But let's just talk about like why this actually works out pretty well as a cloud provider. And sorry, this doesn't tell you explicitly. The Autoscaler, the cluster Autoscaler cloud provider. Why does this work out really well for that? Well, so Rancher is already a multi-cluster manager, right? So you see here, I have a multi-cluster, whatever, bunch of clusters right here, no big deal, right? And I have full access. I have full access to that cluster. And you just saw with the node pools, I have full access to increase and decrease node pool sizes. And the API gives me full access to all these things, which is essentially what you need to do with the, you have a question, Nick? Or you just
actually there was a question on what you just said. Would it drain the pods on the selected node when you scale down?
Fantastic question. I'm actually getting to that very shortly. It's actually pretty cool. So great question. I got you. I'll cover it. Trust me. So here's the deal. You obviously have to have an API to access all these things, right? So, and then you have to write code to make that happen. So there is I'm going to probably stop sharing here. I'm going to stop sharing this one. And I'm going to just quickly walk you through, because this is more of an engineering masterclass. So I'm just going to walk some people through some code here just to kind of see what these things look like, because it's actually quite interesting. So this is actual code of the cluster autoscaler. Let's hope this thing will share. Let's go. Can't see it, can you, Nick?
It's loading.
Oh, there we go. A little bit of a delay, but that's okay. All right, so here's the deal. This is okay, so just so you guys can see it, if anybody wants to go do some Go, you can go do some Go. Here's the Autoscaler repo. Here is the cluster Autoscaler subdirectory inside of that. Inside of that are cloud providers. You'll see a bunch of directories here. I'll open this up a little bit more. You'll see a bunch of directories here for all of these different types of cloud providers. You will see a nice little addition here of the Rancher cloud provider. And then there's going to be this main file here that actually contains all of these. So number one, gives you some constants for what's in there, but it gives you these interfaces. So you are going to want to take a look at what a cloud provider actually is, and then additionally what a node group actually is. So if you're going to potentially write your own provider for your infrastructure, sure. So I'm currently on the media player. I guess that doesn't show it as well. Sorry. So the node group, is essentially a one-to-one for our node pool. So you can see the functions that this thing has to implement are max size, min size, target size, increase size, delete nodes. I mean, it reads very much to sort of the API that I just showed you. And if you actually were to go and look at the code for this, you'll see that the work has been done to essentially replicate Rancher API calls for all of these problems, right? So you want to create a node. Well, that's pretty easy. You can just, you can increment the pool and add it. And you also have, this one is where a lot of stuff happens right here, delete nodes. So delete nodes actually gets you a stack of nodes here. You can see it's an array of nodes, and it says, these are the nodes that I would like to delete. Now convert that into an API call. That's basically all it does. So, if you are thinking that some sort of a cloud provider for your setup could work, it's really not that hard to get in here and get your hands dirty and add your own. It's going to end up being a fork. You can submit it back to that. The Rancher, this thing that you're looking at right here, this Rancher directory is not in upstream Autoscaler. It's just in my branch, right? So I just added it, made an image, whatever, good to go, right? And I deployed it. That's it. It wasn't that hard. So just know you can go in there and you can do that work yourself if you're motivated. And you'll see here, it's very straightforward. Cloud provider has very straightforward set of functions that you can use. Just implement them. Some of them actually don't even need to implement. They're actually pretty generous. They tell you plenty of these are just optional. So you can just go through these and figure out which ones are required. And there you go. So here you go. This one's required. It makes sense, right? You need to be able to increase the size of a pool. All right. Well, there you go. It's forcing you to do it. Okay, so what we lacked, however, in the pre-256 was the targeting of a node, and that ended up making this whole, this function right here, this delete nodes function, that made that a little messy, because if you deleted a node, it would just say, minus the pool, and if that node had stuff on it, it was not always the best thing for everybody in that scenario, right? Sometimes you don't want to stop a pod and restart on another host just because you want to make sure that host is clean, which is actually what the question that was asked earlier is, how do you actually drain and get that node completely clean and ready for deletion? Some people do different things. Let's take an example, right? Let's say let's say you have you're a game company and you have a server you need to spin up to let some players join. When the players all leave, you now can delete that pod, right? You don't care anymore. So you could then taint a node, which basically says no new pods, wait for all of the games to die down and go away. So now you know there's no game servers running on that host anymore. And then when that's done, and this node has capacity that is unnecessary anymore, then the autoscaler can remove the node from the pool. Right, so it's going to watch the metrics, say that this node is not necessary. All the players have left the games have all wound down, and there you go, you're done. You can close the node down. That's kind of a decent scenario for how this would end up working out. So let's look at the closing down of the nodes and how this delete nodes would actually work. If you are going to delete nodes, I'm going to stop sharing the code because I think we're done here. I'm going to go back to the slides for everybody who's keeping track.
Yep, and just Luther, I think you're already aware of this because we discussed, but folks from the client side, it may be difficult for them to know when you're on which one. So we should probably keep double check of that as we change.
Sure. I'll keep mentioning it. Okay, so the API was updated to do a couple of simple things. The most important one is actually the scale down action. I actually really like that. The scale down action is essentially what happens every time you select something in the UI. Select a node in the UI and then hit scale down. It'll submit an action, a post over to that node by ID and say, get rid of it now. I'm done with it. It's fine. The node pool picks it up, realizes that he's going away, and then removes it and decrements the count. Everything's fine. That is the crux of what delete nodes turned into, from the decrementer over into. Thank you for linking that, Nick, by the way. It will end up turning it. It'll take the node. It'll put on a current timestamp and say, get rid of the node. Node pool gets it. He checks a timestamp, says this node's supposed to go away yesterday, and then he gets rid of it. That's basically how it works. So if you're going to write something against the API and you want to scale down a node, put a post against that scale down action. Good to go. That's it. It's not even that hard. The scale down time is a little more complicated. So this is actually the action takes it and says that this is now and get rid of the node. The scale down time functionality is actually if you want to put a time in the future. So like maybe 5 or 10 minutes from now, you want to have the node go away. You basically have to set this RFC 3339 format timestamp on the node, and then the node pool will pick that up, and he will then ultimately take and delete the node at that time. After that time, I should be specific. After that time happens, he'll delete that node. But you got to be careful. This is queued in the Kate client, and if you restart Rancher, do some things like this. Like let's say you set a scale down for like 2 days from now, and you restart Rancher, that's going to be gone. It's not going to be a guarantee that it's going to happen at that same time. So just be a little careful with scale down time in the future. It's not always a complete promise that that'll end up going away. Then there is the question that was asked earlier. How do you actually confirm that the pool is clean and can go away? You have, I'm sorry, not the pool. The node. How do you confirm the node is clean and can go away? We've added functionality for drain before delete now to a node pool. This is actually functionality that I had added earlier to vSphere. vSphere has a problem with storage providers where if you delete a node, it was just thrashing and deleting the VMDKs under the hood. So if you had persistent storage, it would delete it because it was buggy. That was just bad. However, if you do proper drains and do draining before deleting, that VMDK gets moved properly. The CSI, the in-tree cloud provider takes care of it and figures this out. And then that's it. It'll move the VMDK and everything's fine. So I built that functionality for vSphere, and then it's like, oh, that actually would be a pretty sweet functionality for everybody. So we added to node pools so that if you take node pools, you take this Boolean and set it to true, we essentially force a kubectl drain and cordon before we delete the node. We make sure that goes back. If it doesn't, look, there are times where you can drain and cordon node and it doesn't work. It fails. There's nodes on there pods on there that are doing weird things. That happens, and they can fail a couple of times, and then it's going to get deleted anyway. So it's not a guarantee. It's just that we do try pretty consistently try draining, we try cordoning, we try it a couple of times, and we make sure that we at least give it ample time to complete before we delete the node. And that's about as safe as you can possibly be with a Kubernetes cluster. I mean, if the nodes are not going to, if they're not going to drain, they're just not going to drain because you got something on there that's stuck or doing something, and that's just life. And we're going to have to figure out how to make that better. If you go in and actually call the drain, it's about the best as you can do. So yeah, so if you set that, and I'm not sure if anybody noticed it, I'm going to share my screen again and show you the UI here on, let's see, share. I just want people to know that this is not just an API only thing. If you go to sharing, should come up, hopefully.
And while that's happening, Luther, we had a question from Caleb on needing to write custom logic against the Rancher API in order to get auto scaling of a Rancher provision cluster. I believe the question probably has to do more so of, do I have to write my own logic or Go code using Rancher API or Go modules in order to get auto scaling working with the Rancher provision cluster, or any kind of custom thing?
Well, so I mean, we give you the tools. We give you the tools. We do not have any. We do not have a lot of the auto scaling functionality built into Rancher so much as we have the tools to provide auto scaling. Does that make sense? So the reason why I keep talking about the cluster autoscaler is because that is another tool who utilizes the Rancher tools to provide auto scaling, right? So do you have to write custom logic? I mean, you're going to have your own custom reasons for why you're going to autoscale anyway, right? So if you're going to have a bunch of metrics sitting around in a Prometheus database, you're going to probably want to ask it questions of when you should or shouldn't autoscale. Maybe you do that. Maybe you have a Grafana chart, does an alert and says, I'm alerting, and he hits a webhook, and then the webhook hits the Rancher API. I mean, all of these things are perfectly fine ways for you to autoscale nodes. You know, it doesn't have to be through the autoscaler. I just want to make sure you understand the APIs are there, and then I want to make sure you understand how the autoscaler functions and how he utilizes that. And then you can apply it to your situation. You know, people have different monitoring and alerting tools and different ways to scale their nodes. And maybe you write a Python script that scrapes Prometheus every 10 minutes and then makes decisions for you. Maybe that's your thing. You know, it's kind of got to be what works for you. Okay, this hopefully is showing now my UI. Here was my Autoscaler 3, and I'm going to edit the cluster, and you're going to see here this drain before delete is right here, and I can check these boxes. That's it. Just put the Boolean on the node pool, and you're done. So if you have a worker pool, you want to make sure it's drained before you delete the node. That's all you got to do. When those nodes are deleted, I can actually, let's see if this works. This will be fun. Let's do this, do this, do this. I'm going to save it, and I'm going to delete a node from the worker pool, and let's see if it, because you can see here, by the way, you can drain it by the UI, these two buttons up here, but I'm actually going to do a scale down on one of these agents. There it is, cornered it. He drained it, the drain worked out, and he's happy. And actually, this will be even funner since people apparently are asking questions about this. I'm going to go here, projects. I am going to go to workloads and deploy some Xenial. I'll deploy 5 pods, launch it. And we're going to go back here to workloads. And there you go, all 5 are up. I'm going to go to nodes. You'll see here we have 4 3s. I hope it didn't just put, I didn't put 1 there, because he's a worker too. Whatever. So you see this, 6 and 5. So I bet you anything, if I go here, hit scale down, he'll probably drop probably 3 pods will probably move. Let's just see what he does. I think there's usually 3 that are sitting around. Cordoned. See, it's taking a little bit longer this time. So he's actually draining it, actually cordoning it. There you go. See, and 7 moved over to the other one.
So Luther, a quick question. Is this going to be available in Cluster Explorer in the future, or do we know whether or not that'll be the case?
Great question. So Cluster Explorer is our next-gen UI. If you hit this button up here, that'll take you there. The functionality should be on parity at some point in the future. We're working on that. It's a lot of work to do that, though. So the cluster, I believe the cluster managing the node pools, et cetera, creating clusters, et cetera, that's all still in Cluster Manager, and it is slated to be ported to Cluster Explorer. Cluster Explorer is sweet, by the way. It's awesome to navigate and find stuff really easy. It's awesome. It's just that it was kind of built at the same time as us adding more features into Cluster Manager. And so now we just got to make sure they get parity before we can say 100% you're going into Cluster Explorer. I hope that makes sense.
Yes, and I'm a huge fan of Cluster Explorer as well. It's a little more K8s native, and it uses better real estate of your browser. But I honestly like both UIs. I'm very biased there. And as a quick follow-up question, someone asked in chat, could you tell us what's the best way to look at the logs of the pods? I think, you know, you could use the CLI, but perhaps there's another method to do this that we want to share, or maybe the CLI is preferred.
I mean, kubectl is great, right? I mean, it does everything we need, but it's also doesn't always show you everything as a nice and visually laid out, et cetera. We have that here. If you go into, I'm just going to actually do this again. I think I did it while, okay. Workloads, here's the workload that I made. It is just an Ubuntu Xenial, you know, whatever. It's nothing doing anything interesting, right? It's just there running. So if you go here and just do view logs, we have this little pop-up here. It basically does exactly what you would be doing if you did a kubectl logs on the pod. There's nothing in here because it doesn't do anything. So if you want to see something more interesting, I'm going to actually show you, sorry, namespaces here. I'll just do this system. Okay, so let's just go take something that's maybe doing something more interesting, which would be, yeah, cluster agent. That's probably a good guy. So if you go do, oh, sorry, I have to go in and then choose the pod and then do view logs. There you go. There's logs to your pod. So I hope that helps you. Okay, so I'm going to skip ahead to the next slide because it's got a super awesome cow with some VR goggles on that I found on the internet. But I'm going to leave it on my browser because I'm doing a demo. So now let's go see how this thing works. We're going to go back here. Oh, by this thing, by the way, I'm going to actually discuss the cluster autoscaler itself with the Rancher 2 provider. If you go here, so this autoscaler cluster I've already pre-configured. So this is where I'm doing my demo now. If I go to cluster, I go to nodes, you will see I have the server pool, which is going to be all my etcds and control plane nodes. I have 3 of them because I'm going to be adding a bunch of stuff to this. I also have this autoscaler node pool. This is the node pool that I have selected the autoscaler to work against. I have also set it as a minimum of 1 node and a maximum of 12 nodes. Now, if I want to update it myself, I can easily do that, and it'll add another node. And then at some point, the autoscaler is going to get this, and he's going to decide that there's only 5 pods, and there's no reason why we need an extra node, and he's going to then automatically delete him. That's just what he does. He wants to keep it at a minimum of 1 when there's nothing to do. So just to be clear, also, I have this extra pool over here called monitoring. This is where I added a larger instance and I installed our monitoring charts to it, and I gave it more memory because I was actually destroying Prometheus pretty handedly, and I gave it like 9 gigs of RAM and a bunch of other stuff. I just gave it a bunch more firepower because I'm actually keeping metrics throughout this whole process too, and I will show you those in the very near future. So let's just give this a second. So. Just know right now the autoscaler is running. I'm just going to show you. I have him running inside of this namespace system, and then autos. Okay, load up. There's a lot of stuff running on this.
Someone asked in chat, will you present the metrics? They might have meant the masterclass metrics, but I believe they could be talking about cluster metrics as well.
I'll show you the cluster autoscaler metrics. I will be. I'll be showing that. Okay. This is the cluster autoscaler. It's my build of it, so I actually have my version. And then if you view logs, you'll see he's in the background running and doing a bunch of stuff. So just wanted to show you. He's functional, and he's going to eventually go in and take a look, and he's going to decide that he wants to kill that new node. But I am going to do something completely different. I'm going to force him to actually update, and I've done this several times, and it's a lot of fun. So I'm going to go back to, oh yeah, I want to do this in here. Okay, so I have, wrong one. Sorry guys, this UI. There we go. So I have scale test 1 and scale test 2. This is the exact same thing I just showed you, which was the Ubuntu Xenial. I, however, am going to do 250 pods, and I'm going to edit both of them, and we're going to watch what this guy does. So we're going to go here, 250. Remember, the cluster autoscaler bases all of its logic and its thoughts around pods, pod capacity. And if we go back here to the cluster, you'll see here we have 220. And if you did the math, I just added 500. So in theory, we should be adding 3 nodes, maybe, right? That should get us over. Should put us at like 660, 650, something like that. I can't count. That's the demo, because now you got to sit here and wait for this thing to do something. And I actually tuned it to run a little bit faster. There's actually a couple of delays of when it should be adding nodes and when it shouldn't be adding nodes, and when it shouldn't be deleting nodes too. The whole thing's configurable, so you can kind of look through what it lets you do and make it work for you. I set it to like 2 minutes, I think, and I'm hoping this thing's gonna start cranking some nodes.
Perhaps we should. Oh, sorry
take
for
questions
interrupting.
is what we should do.
Well, I was going to say perhaps we should look at the node pool scaling tips slide, since you're already talking about that as well, and then maybe we can come back when it's ready.
That's a great idea. So I'm going to leave it up. I don't want to have to reshare my screen, so I'll just go through the node pool scaling tips that I have, which is another slide. If you guys can see both at the same time, I think you can, and switch over really quickly. Oh, wait, you know what? Actually, before I do that, someone did say they want to see the metrics. So I'm actually going to do that really quickly, because that's actually pretty cool. So I'm going to go to Cluster Explorer. And I had previously gone here and installed monitoring. So you'll see here I have a Prometheus, whatever you say that, I don't even know. And I have services monitored, and I actually added the Cluster Autoscaler right here. This is actually super easy. Basically, the Cluster Autoscaler speaks Prometheus, and he has he's just port 80, 85 or something like that. You can turn him on and he'll start firing. And he'll create an endpoint, and then you tell Prometheus to scrape it, basically, is how it works. But we're going to go into, this back here. Overview, whatever. Okay, so this is the Prometheus graph. You can do this in Grafana. You can do this in anything else that reads Prometheus. I just like the Prometheus graph because it's super simple for what I need. But if you look in here, it speaks. The cluster Autoscaler speaks. Autoscaler. Okay, he speaks Prometheus, which means that when you turn Prometheus on to scrape that endpoint, he will then give his data. And you'll see here that if I zoom out a little bit, you'll see I actually was playing with this demo for a couple of days. Oops, zoom that way. So I was working on it late last night, playing with it, and you can see I scaled it up to 9 nodes, back down. So if you have monitoring set up, you have Prometheus set up, this guy will speak this. You can then use that to keep track of things that are going on. I hope that answers the questions about metrics for the Cluster Autoscaler itself. So the question was, do I need to write custom? No, that's not it. Where's the question about? We'll skip it. I think this answers that question. This thing speaks Prometheus, and you can do it every one inside of that. Okay, so let's see if this has any nodes that are booting up. I'm going to go back to Cluster Manager. That's funny. You have any idea how many times you get asked that question about Prometheus? That's the plural of Prometheus. Go look it up. They actually have a whole wiki thing on it. That's pretty funny. Okay, so I have 250, 145, and I think it's coming up pretty quick. So I think I actually added something. Yeah, boom, there you go. Awesome. So you can see that my other node actually finished creating, and he already has taken all capacity. And then this is now creating, and then when he's up, the scheduler will put pods on them, and they'll be up and running. That's it. Not too bad, right? Also, if I was to do the opposite, which is to delete all those deployments to be 0 pods, it'll do the reverse. It'll just slowly but surely pull these things off, move them around to the right hosts, and delete ones that are unnecessary. Very cool. All right, that's pretty much the demo. There's not much else to show besides it functioning, because I don't really want to dig into it too deeper. So I'm going to stop sharing screen. If you have questions about the demo, kind of what it did, why it did it, just please ask it. I can try to answer. But I'm going to go back into node pool scaling tips. So yeah, as I talked about before, you definitely can do this with any machine driver. This is our machine driver node pools. All function the same. Seriously, metrics are more metrics. You're going to have to make decisions about what your org needs. You're going to have to make decisions on whether it's, maybe it's too many TCP connections, or maybe it's too many, you have too deep of a queue and you need more workers, or you have game servers and you need to, remove some users and put them on and consolidate and, do something different at night versus during the day, or who knows, or maybe you're a Black Friday company and you need to figure out when Black Friday actually ramps up. That's really kind of what your work needs, and you need to have metrics to do that. You're really not going to be able to do any of the scaling without any of that. And at least we have tools here that'll help you scale when you need it. So the Rancher monitoring chart is actually very useful. I installed it here. The Prometheus stuff that I showed you is all just based off the Rancher monitoring chart. You can just go into our little app store, so to speak, and install it, and you'll get Prometheus out of the box, and it'll start doing a bunch of the normal Kate's statistics, and then you can add extra stuff like I just showed you. I added the cluster autoscaler to it. You're also, seriously, this is actually pretty critical. Do not scale everything. You're going to probably want to have one specific worker pool that does one specific thing. You can see here in my demo, or you could see in my demo, that I had a node pool dedicated to monitoring. I actually had a lot of problems in the beginning of this whole thing when I was setting up my demo, where I would actually thrash my monitoring boxes and then it would go down and I wouldn't have any monitoring. Just go ahead, put your monitoring on its own place, have it just sitting there, have Prometheus on its own area. Don't mix everything together. Use taints to make sure people don't put pods on your monitoring nodes. Just make sure everything's clean and nice. Do some good housekeeping in that regard. Node selectors too are great. For instance, in my little demo here, I just use a node selector to target that Autoscaler pool. So when I added more deployments, they just for sure went to the pool that I wanted to autoscale. Just make sure you're doing things in the right place. Also, never autoscale etcd control plane. You're just probably asking for a world of pain. Just try to do it with worker nodes. That's probably a good word of advice. So if you also notice here, I did kind of a fake HPA, the horizontal pod autoscaler. I kind of faked it by updating the deployment and just adding it to 250, right? But if you combine the HPA with a node scaler, you can do both, right? So you start having more people playing your game, then you can add more nodes. So you make the HPA function and say, oh, I have 10,000 players. I should probably have 1,000 pods. Okay, now I have 20,000. I should probably have, 2,000 pods. Okay, there you go. You can combine those things. You can have the horizontal pod autoscaler, figure out how many of those you need, and then you have the node scaler, add capacity to make sure that stuff works out. That's it for that slide. Ask some questions, people, because there's only one more slide, which is ask questions.
Well, I marked 3 questions I've already received, and folks feel free to keep sending them in. But before I start reading them, I just want to say thank you for hanging in with us. I understand that this DM style Q&A is a little different if you're used to live chat. So feel free to use the masterclass channel in the Rancher users Slack if you have something to share with everyone, and especially after this session as well. So I'll go in order of the ones I marked as priority. Does this work with Nutanix Prism, Prism Central, or Calm?
Man, I think that's all crazy view stuff, and I don't think our node driver works with that stuff. So I'm going to say no, except that I'm going to probably defer to our field engineer who does most of our vSphere work, and I'm going to tell you to ask that exact same question in our vSphere channel in user Slack, and then I'll get David Holder to take a look at it.
Yeah,
I'm not good at Nutanix, but I don't think it does.
And even if we don't have this feature as well, it certainly wouldn't hurt to kick off the discussion. Perhaps that leads to a GitHub issue. And then we can work from there. All right, next one. I just thought this one was funny. It said, I need this autoscaler so bad. Please ship it, please. So you can't disagree.
Yeah, you can take my betaware if you want, but you probably want to optimize it a little bit.
We can, same thing as there. If there's anything you've seen in this that's been dev or not necessarily production ready, please feel free to reintroduce it in the Slack, and then we can prioritize it as needed. So the serious answer to that statement is definitely do not be afraid to talk about it. File and talk in some GitHub issues. We pay attention to that stuff. Okay, the next question is the code that you use to drive the Rancher API capture in the GitHub project you shared?
Yeah, so it's going to be in the project that I shared on. Let me find the slide. I'll bring it back. I'll bring it back up. Nope. Yep, this one. Push to audience. Let's see if you guys get that. So it should say Rancher Cloud Provider, and then I have my Luther Monson / Autoscaler. Had some good work. We actually worked a little bit with a customer on this, and they did some great stuff. And then I actually make some functionality additional to Rancher to help provide support for this, and turned out pretty good. I'm actually really happy with how this demo turned out. And I hope you guys are too. So yeah, that's if you go to this Autoscaler. This is my branch, Rancher. The image is up there. You can steal my image. I don't care. Like, it's there. You can play with it. Have fun. Ask me questions if you have them. Hit me up on user Slack.
Yep. All right. We have more questions. They keep coming in.
Cool.
And feel free to message me, co-presenters, if we need to stop at any point. The next one is, does Node Autoscaler manage, or I might have to rephrase this one. Does the Node Autoscaler manage autoscaling groups automatically on AWS?
I don't know. I mean, I can read the docs real quick, but I think that it's really just spinning up and spinning down EC2 instances. I don't think it actually cares about an ASG. I know people like ASGs because it helps you like put a node back in if they get deleted, but like some of the functionality that exists, for instance, in our node pools, we'll put nodes back in if they get deleted. So there's a little bit of duplicate effort. And there was a lot of talk that we had a while back about using autoscaling groups for node pools. And we opted not to. We kept doing the stuff we're doing with the node drivers because a lot of that functionality is kind of duplicated. There are things autoscaling groups do. They will read some of the CloudWatch metrics, et cetera, but you can do that too, and you can make those same requests to the Rancher API. So yeah, I don't know. Autoscaler, does the Autoscaler use ASGs? I don't know. I'd have to look into the code, to be honest with you. I never even used it.
Yep. And feel free, if you feel like we partially answered a question or there's more that we need to know, it certainly would not hurt to, like I've said, the prior things, GitHub issues, user Slack, we're always at those things. When will the node autoscaling feature be available to try out? This seems to be a separate user, but a follow-up to the I need this autoscaler so bad.
I need this now. Okay, actually, to follow up with the person who's talking about autoscaling groups, I actually did just grok the code real quick in the Autoscaler provider, and it does have ASG code here. So maybe it does. I don't know. Haven't used it though. When is the Autoscaler available? It's not. It's betaware. I just made a provider copy some code done by a good dude who did a lot of work, and I updated it to do some more work. So it's not really available per se. Good feature request. Add some issues to Rancher and ask for it, and maybe we'll get that done for you guys.
Yep. So the answer to that one. Like Luther said, this is just in his GitHub repository. So, but we can try and get it to production ready. We actually did, and this is pretty similar to what we've done for other features, such as logging examples, fleet examples. Sometimes we have developer beta repos that sort of end up in the Rancher org, and we use them for use cases like this. So definitely important. Okay, the next one is a network's load metrics part of standard metrics of, okay, I think you clicking everywhere is moving the text for me.
Oh, is it really? It actually changes it for you too,
I'm trying
dude?
to see.
I'm sorry.
Yeah, it's like Luther's answering. Man. All right.
I was trying to, and I guess we both control this box here. Sorry about that.
Yep, no, not a big deal. I'm just kidding anyway. Okay, is a network load metrics part of standard metrics of Prometheus monitoring and Rancher for HPA scaler based on network load example scaling of web servers and apps?
Man, that's a great question. And I also don't deal a lot with that stuff. I literally had to have Arvin walk me through all of that stuff last night. So I don't know. Let me go look at the Grafana charts that we make for it, because it's possible. Sounds likely.
I think this would be a good thing to forward to our monitoring section of our user Slack as well. It's pretty well active, and our coworker Arvind is the SME for that. So that might be a cross collaboration, but we can probably answer that for you for sure, Peter.
Yeah.
Okay, we do have a lot of time, but I'm still going to move quickly here because I can talk a lot.
By the way, I put up this Ask a Rancher Dev Anything. Like, I seriously, like, this is kind of the areas that Nick and I both work in. So if you see other things here too, we probably can answer them if we get done with a lot of this autoscaling stuff. So we have a little bit of time and we're booked, so we might as well just spend it with you guys.
Yep. We have autoscaling at the pod node cluster level. Is it Rancher's custom implementation?
I don't know what your implementation is. What I just showed you was me setting up a bunch of stuff by hand, so it's not like we did anything for you. I'm not sure I understand the question.
I think the user is wondering if this is perhaps managed by CRDs via Rancher controllers, or if we're using native Kubernetes resources, so folks can get started with this on a non-Rancher cluster or anything similar.
Well, I can explain that node pools, nodes, those things, those operate out of the Rancher local cluster, and those things are controlled by the Rancher API, and those are CRDs, and we have all that functionality built into Rancher. If you install Rancher onto a Kubernetes cluster, as it works kind of as a normal controller or an operator would, you'll have access to those things via the Kubernetes API as well. Highly recommend you don't modify them, though, to be honest, because you could mess some stuff up. You really should just access those things through the Rancher API. And you have all those things today. The HPA, but you don't have any. The HPA stuff is Kubernetes itself. That's actually a downstream thing that would happen in the cluster. I don't think I answered Peter's question. Peter, you can hit me up later if you have more details you want. I'm not sure.
Yeah, I think we need to definitely circle Arvind into that as well. So apologies, Peter, but
Okay.
we'll try and get you that answer for sure.
Yeah.
All right. I'll tackle this one. Is RKE2 the future, or will RKE1 be around forever? This is a really great question. RKE2 is evolving very rapidly and has multiple projects in one from my perspective. Our official marketing on it, just so I make sure I don't screw up things, is RKE2 combines the best of both worlds from the 1.x version of RKE, now it's called RKE1, and K3S. So, you know, it also has a lot of great security features as well, particularly really nice for folks that work in the government sector. So RKE2 and RKE1 do a lot of different things, but RKE1's provisioning aspects we have slated to try and put in RKE2. I cannot give you an official answer on this other than, you know, if I was a user in the community, I would be really excited about RKE2 potentially heading in that direction. So my answer to you is I cannot say for sure because this project is evolving every day. Our official RKE2 docs have more of a better answer, but I would be excited at the prospect of RKE2 being everywhere because it really is a combination of a lot of our best work.
Just also something that people need to be very understanding and clear about. Docker as the main source of the container runtime is more or less going away. It's going to have the shim layer, et cetera. And Containerd is taking over in some of these spaces too. There's other CRIs, who knows, but our RKE1 implementation is Docker. So really what it comes down to is there needs to be a second generation that supports the CRIs now, right? Like it's gotta evolve, and RKE2 is coming along fantastically. If anybody's in Gov, like it's FIPS compliant. I mean, it's great. Like it's got a lot of stuff in there that people could use. So, yeah, are we going to work on both of them? We are. RKE1's not going away. I've already been told that. So,
right. We have a huge commitment to RKE1 and a very loyal user base there. However, it is worth noting just for folks that are, you know, in the future looking at new things, building new clusters and that kind of stuff. Docker shim is not to be confused with the Docker building and Docker pushing and the actual container runtime, even Docker run. It's just CRI for Kubernetes that is being deprecated. So RKE1 by extension is a little, is in that path, even though we plan on supporting it. So apologies if that answer was a little broad. I think Luther summarized it a little better than I did. But we are basically committed to our loyal RKE1 users. But definitely, if I was a new user, I'd be excited about RKE2. Okay.
Great question. Follow up on that, though. Is there going to be a migration path from RKE1 to 2? That's a tough question. There's a lot of stuff to migrate. I don't know.
I think
We've talked about it. I'm not sure. Are we committed on anything? I haven't heard.
We are hoping.
Yeah, that's what I think so.
Hoping, and actually, if you look at the RKE2 docs, it says an upgrade path from RKE1 to RKE2 is also under development for those who want to migrate. I think what Luther and I want to do is not necessarily promise a 100% migration path that's coming out in X amount of months. A lot of this is exploring. One reason why I'm working here is because I love that we're at the bleeding edge and trying this new stuff, but in consequence, that means we're not necessarily sure something will ship. Something might be a great idea that we try out, and we say after a while, you know what, it can't exactly look like this, or it needs to be tweaked or tuned a certain way. So apologies for a bit of the corporate answer there, but I think it is definitely on the table for sure, the migration path. Okay, Luther is answering questions in chat, but Luther, actually, we might want to echo some of these because chat is not a live chat so much as it's a private DM inbox Q&A.
Good point.
So some of these we might actually want to echo back out to the audience. Okay, one more RKE2 questions. Is it considered stable for new users? I
think so, isn't it?
It's considered stable, but it is not feature parity. So I think from a Rancher perspective, like actually, if you're using Rancher, like the actual Rancher, you can run it on RKE2 clusters, from what I understand. I run my Rancher clusters on K3S usually, my local cluster. So my answer to you is not feature parity, but is stable as a Kubernetes cluster, from what I understand. There's a question on the monitoring and metrics channel. I will get that answer to you right now, but Luther, there's the auto scaling through the Rancher API versus the cluster API way. Do you want to handle that one while I'm looking for the monitoring channel?
Yeah, so the question is, do you recommend autoscaling through the Rancher API, the node pool way, or through the cluster autoscaler, the cluster API way? Cluster API is not really full featured yet, and not everyone has implemented all the backends to it. There are people working. I think I mentioned the VMware guys doing the vSphere stuff. It depends if what you're running on supports cluster API, and you got to probably do some due diligence on your side. Me personally, cluster API is just a thing. I have node drivers that make clusters perfectly fine, that I don't really need it. So I can't honestly speak one way or the other because I don't use it. I don't really care about cluster API at this present moment. I'm not writing cluster API integrations. I don't care. So sorry, I can't really give you a definitive answer. Except for because I write the other stuff, do that. I don't know. Sorry, I'm not sure that's a great answer, but.
And to answer the monitoring channel question, I have misled you. The user Slack does not have a monitoring channel, but if you post in general, and you can feel free to CC me and Luther, and we can take some eyes on it. Or the masterclass channel. So again, if by default we maybe mention a channel that doesn't exist, it's because we're popping in and out of multiple Slacks all the time, trying to make sure we help as many people as possible. So feel free to default to a general or a masterclass channel if we mention something that does not exist, or suggesting that we maybe should make one. I am going to, this RKE2 question's done. This one is done as well. This custom implementation one is done. I thought someone had mentioned monitoring a metrics channel. Yep, that was by accident. One does not exist. I am forgetting that, our user Slack channels can sometimes be different than our internal, and sometimes we are involved in other communities as well. Like I'm in the Bonsai Cloud Slack for logging, for particular. So our fault, not a monitoring channel, but you can use general or masterclass or something else that may fit your question, and CC Luther and I in the thread, and we'll help you get it answered. The only last question I don't think we answered directly that I see, and feel free to keep asking, folks, we still have time, is I have a feeling that catalog management is a bit clumsy at the moment. I believe this is in regard to Cluster Explorer. I had, or maybe not actually, I had several issues with a dying etcd because of Rancher inhaling a lot of CRDs. I also saw Rancher dying because of a corrupt index.yaml in a Helm repo. Are you working on this?
That was a question for me. I thought you were going to answer it.
So
I wrote the answer in there, by the way. So you and I both don't work on any of the Helm chart stuff. Well, sorry, we don't work on the catalog being weird like that. That's not really sort of our domain. So I suggested to this person that they should submit issues. Like when in doubt, submit a Rancher issue. Go to github.com/Rancher, submit an issue, and we can triage it and figure it out. As far as it blowing up to etcd, yeah, that happens. etcd's fickle. Yep. And inhaling a lot of CRDs. Yeah, we do that too. I guess dying because of corrupt index YAML. That's a weird one. Submit an issue on that one for sure. Like that doesn't make any sense.
Absolutely. And folks, do not be afraid to create issues, talk in the Rancher Slack. Worst case, we just don't see them right away, or we mark them as duplicate. But we are monitoring these things. There was a question on Windows containers.
I'm totally taking that one. So yeah, so Bradley, salt of the earth, that guy. Thank you for asking about Windows containers, my bread and butter. Windows container support or containers on Windows. I think it's technically both. So you can't actually, the Windows kernel stuff is too crazy. You cannot actually support Windows on Linux. So if you're thinking that we were talking about like .NET Core or something like this, we're not. We're actually talking about legit Windows, Containerd and Docker Enterprise, essentially, running Kubernetes. And it does work. If anybody has Windows workloads today that they prefer to be containerized, it works. It's functional. I work on it day to day. It's fantastic. There's a Windows Slack you can join. The user Slack does have a Windows channel. That one is for sure. I've been in it. Go ask questions about Windows, because we're going to be adding some RK2 Windows support, and we're going to keep moving on Windows stuff. It's pretty cool. Now, Rosavaldo asks if we have docs around this feature. I'm not sure which feature that is. The autoscaling feature? We got a ton of docs about node pools and how to up them and down them, and the scale down functionality is documented. It's all in our docs.rancher.com stuff. So yes, I think we have docs around this feature. I think that answers your question. Not sure.
I think that is all of our questions. We'll hang out here for a little more if you folks have more questions.
Well, I guess let Connie wrap this up. She's got her little post-table thing she can do.
Oh, true. True, we need time for that. So I guess the last thing for us on the Q&A section before we hand it over to Connie. And by the way, Luther, thank you so much for presenting this.
Yeah, cheers. Thanks for being here, man.
Oh, wait, there's a... All right, I'll answer this one really quick. Then we'll hand it off. Sorry, Connie. Are there downsides to having a mixed Linux and Windows cluster? There shouldn't be. And if there are, you should let us know, because we need to fix that. That is literally Luther's job on our new Windows team, is to solve questions like that.
We want it seamless. Yeah.
I worked on shipping logging v2, logging v1, and fleet to Windows. So those things in particular, you can let me know about in the user Slack. The answer should be no. In fact, there should be a benefit, right? Like maybe now you don't need your .NET applications running on Windows hardware anymore. Now you can have them all in the same cluster. So if anything, there should be a benefit to having both. Okay, I will cut questions off there to give Connie time to wrap this up. Sorry about that, Connie. And thank you all so much. Feel free to ask more in the Slack. And seriously, thank you, Luther. I learned a lot today, and I think a lot of chat did as well. So really appreciate that.
Great. Thank you, Nick. Thank you, Luther, both for a great session. And everybody, lots of great questions today. So feel free to continue the conversation. What you see now here is just a highlight of our products and projects. All are open source, obviously. So you can head to rancher.com to try everything here hands-on. And just a few additional details to wrap up today. Our April online meetup is coming up in a couple weeks. This will be on Wednesday, April 21st. And we will be talking about a new project named Hipper, which is super exciting. So head over to rancher.com/events to find out more about the event and also for to be able to register for it. And then as I advance these slides here, for those who might not be familiar, we have some additional training resources around Rancher and all of our products. So rancher.com/training has more of an intro style training to get familiar with Rancher if you're not as familiar with it today. If the content today was a little bit too over your head, head over to rancher.com/training. Or if you want to get certified to become a Rancher operator, you can do so at academy.rancher.com. And I believe that wraps it up for today. Thank you again, everybody, for attending today and sticking with us through this new platform, which I think worked out pretty well. Luther and Nick, I think,
Yeah, this is great, actually. It's the questions came through real nice. I hope everybody was answered appropriately with this. I hope the feedback got back to the people. We don't know if that worked out, but no one asked second questions. Timing on everything was really good. It's just pretty solid. Good times.
Connie, I think there's one more question or Luther in chat about a new Academy Rancher Operator Part 2, seems like.
Yeah, I am actually not sure. I know there probably is a plan to do that. I'm not sure when that will be available. The best place to find that out would be our SUSE Rancher community page that I mentioned earlier. I will include that in the follow-up email along with the link to the recordings and the GitHub repo and the slides. So everybody that attended today will be receiving all of those links via email. So that wraps it up for today. Thank you again, everybody, for joining us, and hope everybody has a great rest of their day.
Thank you.
Bye.